According to the continuity equation, the cross-sectional area of the pipe and the fluid speed are always equal at any given location along the pipe. The volume flow per second, also known as the flow rate, is the same as this product. A continuity equation, also known as transport equation. It is an equation that describes the movement of a certain quantity. It is denoted as R is equals to A, V is equals to constant. It can be generalized to apply to any substantial quantity, but it is especially straightforward and effective when applied to conserved quantities. The conservation of energy concept as it applies to flowing fluids is stated by the Bernoulli equation. The reduction of fluid pressure in locations where the flow velocity is increased is the qualitative characteristics that is typically referred to as Bernoulli effect. Although this reduction of pressure in a flow route restriction may appear conductory, it becomes less so if you think of pressure as energy density. Pressure energy must decrease as kinetic energy rises in the high velocity flow through the restriction. The Albert Einstein formula, commonly written as E is equal to mc2, demonstrates that when a body's energy changes by an amount E in whatever form it takes, its mass m changes by an amount equal to E C2. This formula expresses the principle of energy conservation, the conversion of a mechanical energy to thermal energy as a result of frictional effects is considered mechanical energy loss in fluid mechanics and is thought to be convenient to separate from thermal energy. When determining the flow, pressure, or energy loss in piping systems, minor flow losses in the pipes play a significant role. Due to the forces acting on it, such as pressure and gravity, liquid moving through pipes carries momentum and energy. When we say major losses occur due to friction within a pipe, and a minor losses occur at a change of section valve, bend, or the other interruption, major losses occur due to the friction effect between the moving fluid and the walls of the pipe. Any disruption to the flow, which is primarily brought on by the installed fittings on the pipeline, results in the modest losses. Let's talk about real-life application of fluid mechanics. Utilizing lotion. In reality, you are exerting pressure on the container when you squeeze it to release the lotion. The lotion also gradually slides down the side of the container once it is upright. Shear forces are present because of the lotion is rubbing against the container sides. This instant exemplifies the co-wet flow. When we wash dishes, the extra soap on the dishes made them slick while I washed dishes today. I understood that this was happening because the dish was being kept lubricated by the soap. The viscosity of the soap lowered the plate's exposure to the shear pressures. This is why the plate keeps slipping out of your hands. Let us discuss about the continuity equation formula. A1V1 is equals to A2V2. A1 is representing cross-sectional area of region 1. V1 is representing flow velocity in region 2. A2 is representing cross-sectional area of region 2. And as you can see, V2 is representing the flow velocity in region 2. Let's talk about the Bernoulli equation formula. As we can see, the formula is given wherein the letter P representing the fluid density, letter G acceleration due to gravity, P1 is equals to pressure at elevation 1, V1 is representing the velocity at elevation 1, H1 is representing the height of elevation 1, P2 is representing the pressure at elevation 2, and lastly the V2, velocity at elevation. My lifelong learning is that I learned that I use fluid mechanics in everyday life without realizing it until I am with this lesson. This lesson gives me a lot of knowledge and a lot of things to realize in everyday lives.